Namaste. Welcome to Indian Knowledge Systems Primer Course for Children. We are starting the series of lecture on Indian astronomy. In this session, we will offer an introduction to Indian astronomy. We will try to understand a lot of foundational principles that are enclosed in this subject. We'll start the session with a small verse. Yatashika mayuranam नागानामनयो यथा तद्वत् वेदांग शास्त्राणां ज्योतिषं मूर्धनि स्थितम्. This is a beautiful verse from Lagada's Vedanga Jyotisa. That is the text from which it is taken. It's dated to approximately 1400 BCE. So this verse means that like the crest of the peacocks, like the jewels of the serpents, so does the science of astronomy, the Jyotisham, stands at the head of sciences to the Vedas and the Vedangas, which are ancillary sciences to the Vedas. So, Veda Anga, meaning it's a part of the Veda, limbs of Veda. So, Vedanga, there are 6 main aspects to Vedanga. We will shortly see what Vedanga is. So, there are some versions of the same verse which says Ganita instead of Jyotisham. So, definitely mathematics and astronomy have developed together with astronomy, creating the contextual relevance and need for many mathematical processes to progress to happen. In the very ancient knowledge systems, along with the Vedas, there are 6 Veda Angas, Shad Veda Angas, which include Shiksha for phonetics, Kalpa, which gave out how to conduct various rites, various ceremonies and rituals, Vyakarana, which gave out the grammar, Chandas for prosody, Nirukta, which was to do with etymological sciences, and then came Jyotisha, which is astronomy. Since then, since the very old Vedic age till today, the people date Lagada's Vedanga Jyotisha to roughly about 1400 BCE. Some say it could be even earlier than that, but some say it dates to around even 1200 to 700 BCE. So, it is the very first known text in the Indian astronomical tradition, dedicated to Indian astronomy specifically. Moving on. As we can see in India, Jyotisha Shastra, that is the science of astronomy, has fascinated our civilization from time immemorial. And astronomy is even regarded as many of the earliest of the sciences in itself, which gave out, like we mentioned earlier, which gave out the contextual need and relevance for a lot of mathematical progression to happen in the country. Jyotisha itself means illuminous bodies. Another name for Jyotisha is Nakshatravidya. The emphasis here is because we use the stars as a frame of reference to understand the motion of other grahas. Grahas can be very loosely translated to planets, but they are not exactly planets. Grahas are actually entities which have a very special motion. We will define what a graha and deal with it deeply in the coming lectures. So, there is another name for the Jyotisha Shastra which is otherwise called as Kala Vidhana Shastram. Such different names are given to Jyotisha Shastra, which is Indian astronomy. The Indian astronomical tradition is very, very ancient, especially from the period of 1400 BCE to even as recent as 19th century. There has been very deep and rich scholarly articles and texts that have been published. Vedanga Jyotisha, one of the foremost texts specifically dedicated towards Indian astronomy, written by Lagada Maharishi, was done during the 1400 BCE period. Later, Siddhanta Darpana, written by Samanta Chandrasekhara, was published as early as 19th century. So, we can see that Jyotisha Shastra's knowledge system has been very much alive throughout this period. One can understand that the knowledge of astronomy has been a living tradition, especially because it is intertwined, it's an integral part of the social and religious life of the Indian ethos. In India, we can find examples of astronomical ideas all the way from rock art and megalithic structures, which sort of date back to at least 7,000 years, and to the mantras in Vedas, which date back to about at least of 5,000 years. All of these have astronomical phenomena mentioned in them. To megaliths, to archaeoastronomy and to computational astronomy, there are a lot of texts. All of these are mentioned in numerous manuscripts. Some researchers even estimate that there are at least about 9,000 original source works in Indian astronomy. That's a huge number. Broadly, Indian classical astronomical sciences, which is the Jyotisha Shastra, can be divided into two main categories. One is Ganita Jyotisha, another is the Phalita Jyotisha. Ganita Jyotisha is purely astronomy, while Phalita Jyotisha is astrology. So, Ganita Jyotisha, at least today, the word Jyotisha seems to largely have a second connotation of astrology, which is not really the case, because we have different categorizations specifically in the Jyotisha Shastra itself. So, Ganita Jyotisha deals with the mathematical and computational astronomy, while Phalita Jyotisha has got to do with astrology, which has a lot of various heuristics on possible patterns and predictions that we can do in life. That's what is Phalita Jyotisha. We in this course will be focusing on the astronomical division of Jyotisha. In the Vedic times, Jyotisha was given very huge importance, mainly because they had to perform various yajnas, and these yajnas have to be conducted in a very specific time, and all these rituals as well as had to be conducted in very specific times. So there was a pertinent need to sort of calculate an appropriate time, accurate timing. This way, the whole body of science became very important. It is also important to understand that the primary objective of Jyotisha is Dik Desha Kala Jnanam, which means Jyotisha Shastra as a body of science is used for calculating Dik, Desha and Kala. Dik is direction, Desha is location and Kala is time. All these three factors, as we are going to see in this course, can be deduced very carefully by observing the sky and performing certain mathematical calculations. Isn't that interesting? This is a very exciting field of study. So, let's try to sort of, chronologically understand how the evolution of Indian astronomy especially happened. We just saw that how astronomy gave a beautiful context for mathematics to develop. So, we can understand that both the field of astronomy and mathematics were developing hand in hand, and the chronological evolution can be divided into three main parts. One is the Vedic or the pre-Siddhantic era, which dates from 1400 BCE to 500 BCE. We just saw Vedanga Jyotisha, written by Lagada Maharshi, was during this period specifically. The second part is the Siddhantic or the classical era, which is from 400 to 1200 BCE. You need to understand that the Siddhantic era, the classical era, is where we see huge number of works on the entire knowledge system being systematized completely. This happened during the Siddhantic era. Post-Siddhantic or the medieval era, which is from 1200 to 1850 BCE. This had a lot of invasion, a lot of invaders came up and their knowledge systems also had certain impact and so on. As well as we still see huge original ideas getting developed during this period. A special mention here is the development of the Kerala school of astronomy. It made huge strides in this period, both in mathematics and astronomy. In due course, we will try to get a glimpse of all of this. Though the earlier known text in Indian astronomy is that of Vedanga Jyotisa, a lot of astronomical ideas, concepts and various related procedures and processes were also found in Vedic Samhitas, Brahmanas and allied literatures, which were from a much earlier period, much earlier than the Vedanga Jyotisha period. This is a very important point to note. So, one can clearly understand that India's roots in the long running pursuit of excellence in Jyotisha and Ganita. For the performance of Vedic sacrifices, as we had mentioned earlier, precise time prescribed by the Shastras had to be followed. So, it was necessary to have accurate knowledge of this, and hence it was necessary to also make it available and accessible. So, we clearly understand that there was a very important and a significant need to sort of assess and calculate time so that these rituals can be taken forward. So, astronomy at that time seems to have been centered around the sun and moon, and it aimed to study the natural divisions of time caused by the motion of sun and moon, such as days, months, seasons and years. And there were also special attention that was being paid to study of the times of occurrences of new moons, full moons, equinoxes and solstices. Let's now try to understand what were all the things that we had inferred and deduced, especially with respect to astronomical phenomenon in the Vedic literature. So, the moon was called as Surya Rashmi, which means one which shines by the sunlight. We were also able to see that the dependence of the moon's phases on its elongation from the sun. It was mentioned in Shatapatha Brahmana. So, what does this elongation mean? It's a very specific and an important term. Elongation in astronomy means the angle that an observer measures between two celestial objects. Let's assume that the sun is here and the moon is here. So, when we say elongation, it's the angular distance between these two celestial objects with respect to the observer. So, it sort of, if you can say, it sort of calculates or captures the longitudinal difference between the two celestial objects. We will see more on this in the coming lectures. In the same text, it denotes that the moon's path was divided into 27 or 28 equal parts because the moon took about 27 1/3 days in traversing it. So, all such important facts have been already mentioned in the Vedic literature. Taittiriya Brahmana, for example, gives the name of 28 nakshatras with Abhijit also. Abhijit is now called as Lyra. The Shatapatha Brahmana gives the names of 27 nakshatras and their Upanakshatras as well. Some more facts include, marking of constellations, which are basically group of nakshatras. They were also very well known from the Vedic times. Rikshas, which is the great and the little bear, the constellation Great Bear and Little Bear were called as Rikshas. And the two divine dogs, which is Canis Major and Minor. The heavenly boat, the Argo Navis, all of this were, and then the Arsa Major, which is the Saptarishi Mandala. All of this finds a mention in a lot of Vedic literature. The Aitreya Brahmana mentions a constellation of Mriga or deer, which is Orion, very famously called as Orion. And the star is Mrigavyadha, which is Sirius. That also finds a mention in Aitreya Brahmana. Ulka, which are meteors, and Dhumaketu, which are comets, they also have been mentioned in the Vedic literature. So, can you see, we were able to sort of observe, understand, discern and make a note of all this, and we have had such a rich literature tradition dedicated to Indian astronomy. In the Vedic literature, eclipses have also been mentioned, and they are mentioned as being caused by Swarbhanu or Rahu. So, we can see that such rich astronomical phenomena and events have been embedded in the Vedic literature. But specifically in the Indian astronomical tradition, the earliest known text dedicated purely to astronomy is the Vedanga Jyotisa. As we discussed earlier, it is the Hindu work dealing exclusively with astronomy dating back to approximately 1400 BCE. It was written by Laghada Maharishi. So, Vedanga Jyotisha came down to us in two recensions. One is the Rigvedic recension, which is also called as Arka Jyotisha, and the other is the Yajurvedic recension called as Yajusha Jyotisha. Their verses clearly give the Indian calendrical system and accounts of months, years, days and day divisions. It also explains about nakshatras, new moons, full moons and seasons occurring in the cycle of 5 solar years. The author of Vedanga Jyotisha, identified as Laghada Maharishi, is a very phenomenal sage and scholar. However, precise details about his life and times remain largely unknown. So, starting from Vedanga Jyotisha, we have had a long living tradition of Indian astronomy. Numerous authors, numerous astronomers have spanned across the 3 eras and all of their works have been documented by various researchers. We are trying to present a very small glimpse in this list. This is very important for us also to understand, because these names which have been standing the test of time should not be forgotten. These are the great contributors who have advanced the knowledge system for such a long time. Starting from 1400 BCE, where Laghada Maharishi gave Vedanga Jyotisha, followed by in 800 BCE, Shulbakaras gave Shulba Sutras. In the 1st century, Vriddhagarga gave Vriddhagarga Samhita. In 4th century, Vararuchi gave a phenomenal text in Indian astronomy called the Chandravakyas. Chandravakyas basically contain set of statements which detail about worldly wisdom. But these Vakyas are encoded in the Kattapayadi system. We saw what Kattapayadi system is in the Bharatiya Ganita lecture series. So, using the Kattapayadi system, the Vakyas encode the true position of moon for every day in a lunar year. That's a phenomenal work. So, aspects such as where the moon will be in that particular day, what will be the celestial longitudinal angle, all such details have been captured. Captured in the Vakyas of this text. Isn't this a very fascinating work? Let's move on. So, we all would know Aryabhata's name thanks to ISRO. So, next comes in around 476 CE, we had Aryabhata 1. Two phenomenal works of Aryabhata have been Aryabhatiya and Aryabhata Siddhanta. Aryabhata is a genius scholar whose contributions have been well known in the fields of both mathematics and astronomy. Aryabhatiya, the phenomenal work, is divided into 4 parts, 4 padas, which is Geetika Pada, Ganita Pada, Gola Pada and Kalakriya Pada. Then comes Varahamihira, known for the text Pancha Siddhantika. It is said that there were 18 Siddhantic texts. Siddhantic texts are system of works that capture the theories and principles about various astronomical phenomena. They also give the computation to the tune of the Mahayugas, which are very large periods of time. Among those 18 Siddhantas, it is said that today we have only the compilation of Varahamihira's 5 Siddhanta available with us. Then came Brahmagupta in about 598 CE after Aryabhatta. In fact, Brahmagupta challenged many ideas of Aryabhatta and has done phenomenal work for the advancement of math and astronomy in many ways. Some of his significant texts include Brahmasputa Siddhanta and Khanda Khadyaka. Then came Bhaskara I in 629 CE. We owe it to Bhaskara because he was the one who wrote Aryabhatiya Bhashya. If not for his work, we would not be able to understand the cryptic text of Aryabhatiya. For propounding these concepts further, he then wrote Mahabhaskariya and Laghu Bhaskariya. Then came Haridatta, who gave the work Grahachara Nibandhana, followed by Devacharya giving Karana Ratna. Then came Lalla, who gave the captivatingly titled work called Shishyadhi Vriddhita, which means the Dhi is brain. The Shishya's brain will grow manifold by reading the text. Then came Govinda Swamin, who gave the commentary on Mahabhaskariya. Govinda Swamin is also an important scholar because he was the one who sowed the seeds for Kerala school of astronomy. It flourished so well post that. Mahaviracharya gave the work Ganita Sara Sangraha. The Jaina mathematician Mahaviracharya gave the work Ganita Sara Sangraha in about 850 CE, followed by Prutudaka Swamin, who gave the work Vasana Bhashya on Brahmasputa Siddhanta. Vateshwara gave Vateshwara Siddhanta, making further corrections and observations to various work presented in the Siddhantic text, which captures the astronomical data of large periods of time. What are these large periods of time called as? Mahayugas. We just saw recently. Then came Manjula, who gave Laghumanasa. He gave, this is a very important contribution to the Indian astronomical tradition, because in order to arrive at the correct position of moon, he gave the second correction. Then came Aryabhatta II, who gave Mahasiddhanta in 1915, followed by Udaya Divakara, who gave Sundari on Laghu Bhaskariya. Sundari is a commentary text. Then in 12th century came our very favorite and famous Indian mathematical and astronomical scholar Bhaskaracharya. His 5 great texts, namely Leelavati, Bija Ganita, Karana Kutuhala, Vasana Bhashya and Siddhanta Shiromani, are very famous. In Siddhanta Shiromani, this is a pure astronomical work dealing with planetary motions, determining instantaneous velocities as well as the longitudes, in addition to various other astronomical factors. In 1340 came the greatest minds of Indian mathematics and astronomy. His name is Madhava. He belonged to the Kerala school of astronomy. He hailed from Sangamagrama in Kerala. He made some path-breaking discoveries, including the infinite series for various trigonometric functions in pi. He also sowed the seeds for birth of calculus in India. He is one of the greatest minds definitely in mathematics and astronomy. Then in 1500 CE came Nilakanta Somayaji from the same Kerala school of astronomy. His phenomenal work Tantra Sangraha is very well known. His revision to the planetary model is also a monumental contribution. We will see in this course what were the other contributions made by Nilakanta Somayaji as well. Then in 1639 CE came Nityananda, who was a court astronomer in Akbar's period. He propounded the work Sarva Siddhanta Raja. Such a tradition continued for many years, and until about 1899, where we have the work called as Siddhanta Darpana, written by Samanta Chandrasekhara. So we can very well see such an entrenched, rich mathematical and astronomical tradition has been live for so long. Given the current educational context, it is very, very convenient and easy for us to recall Western thinkers such as Galileo, Kepler, Copernicus, Tycho Brahe, etc. But we are very deficient when it comes to knowledge about our own great thinkers who have actually worked so hard to keep the tradition alive. They have nurtured such a rich and advanced knowledge system for so long. In this course, thus, we will try to unravel the fascinating concepts of Indian astronomy. Thank you.